This is the recording for Unit 14 review. For this review, you need to have out your topics packet. Also, if you need to check your homework, I will put those answers up. It's also very helpful for you to have a calculator. These are answers to assignment 14-7. If you need to check your answers and need more time, please pause the video at this time. So our objective on this review is I can factor polynomials and solve quadratic equations by factoring or using the quadratic formula. So we're going to start off by factoring. Let me get my calculator back up here. When we solve by factoring, we're going to use our 4 steps. The first thing we're going to look for is there a GCF? Look at the number in front of the x squared. So there is no GCF. There is not a number in front of the x squared. There's no GCF. 2, we're going to look for our sum and product. Our sum is the number in front of the x, that's the -4. And our product is multiplying the coefficient of the x squared, which is a 1 since it's not shown, and our constant of -32, that gives us a product of -32. Next thing, we're going to use our calculator to find our factors. Some of you may be able to, in your head, determine what two numbers multiply to give you -32 and add to give you a -4. If you cannot do that, we're going to use the calculator. You type in the product, -32 divided by x. In the y2, we do -32 divided by x plus x. Go to second table or second graph, and then we're going to look for our sum in our y2 column. I can see here's my sum of -4 in my y2 column, so my factors are 4 and -8. Last, we're going to rewrite it using our parentheses. There's no GCF, so no GCF to put in front, but our factors was a +4. We put a +4, and a -8. We put a -8. So in factored form, we have x plus 4, x minus 8. Our second problem, same 4 steps. Again, it's asking us 2 factors, so we're just rewriting as 2 factors. We're going to start with GCF. Let's look. I see an 3 in front of my x, and I also notice it has an x cubed. So I'm going to check to see, does everything else have an x? And sure enough, so I go with the x with the lowest exponent, which is a 1. Our GCF is 3x, so I'm going to factor out a 3x. That means I need to divide every single item by 3x and see what's left over. My GCF is out front. The 3's will cancel, and an x cubed divided by x, that will leave me with 2 x's on top of x squared, plus 24 divided by 3 is a +8, and then x squared is 2 x's, and then 1 x on bottom leaves me just 1 x, and then plus 21 divided by 3 is a 7, and then my x's will cancel each other out. Now that I have a trinomial with x squared, a quadratic, I can now determine what's the sum and the product. My sum is the number in front of the x, that's the 8. And my product means I'm going to multiply the coefficient of the x squared and my last number, that gives us a 7. I need 2 numbers that will multiply to give me 7, but add to give me 8. I can think of those immediately, so this is 7 and 1. 7 times 1 is 7. 7 plus 1 is 8. And last, I need to rewrite it. I do have a GCF, so I'll put that first. Our variable was x, and then we have our factors is a +1 and a +7. So my answer is 3x, x plus 1, x plus 7. Problem number 3, we're still factoring. So now I'm going to end up with something times something. First step, GCF. There's not a number in front of the x squared, so there is none. Second step, I'm looking for my sum and my product. The sum is the number in front of the x, so that is 11. My product, we multiplied the coefficient of the x squared, and our last number, we get -42. Our next thing is to come up with the factors. What multiplies to give you negative 42 but add to give you 11? Can't think of that off the top of my head, so I'm going to put that in my calculator. Negative 42 divided by x in y1, and in y2 I do negative 42 divided by x plus x. I'm going to do second graph. In my y2 where I put the plus sign, it's where I'm going to look for my sum. I needed to add up to a positive 11. Immediately I see a negative 11, but I need positive 11. And I look down and see I'm getting positive numbers as if I go down, so I will scroll down in my x column and find where my y2 equals 11. So my two factors are 14 and negative 3. Last thing is to rewrite it. My variable is x, the two factors is plus 14, and now minus 3. So we have x plus 14, x minus 3. Problem number 4. Use our same steps. First thing, is there GCF? I look in front of the x squared. Yes, we have a 6. Well, there is a 6. I only have x's with my x squared and the 72, so x is not part of the GCF. It's just 6. Let's rewrite it with the GCF factored out. So we'll divide everything by 6. 6x squared divided by 6 leaves us with x squared. Minus 72 divided by 6 will leave us with 12x. And minus 78 divided by 6 is 13. Now I can find my sum and product. The sum is the number in front of the x. That's a negative 12. Take the sign with it. The product, I multiply the coefficient of the x squared, which is 1, times my last, negative 13. So 1 times negative 13 is negative 13. Next, I want to find the factors. What two numbers will multiply to give you negative 13 but add to give you a negative 12? I'll get negative 13 and a positive 1. Multiply gives me negative 13, add it gives me a positive 12. Now I can rewrite it. GCF goes first, and now I'll fill in my parentheses. Minus 13 plus 1. So my final answer is 6, x minus 13, x plus 1. If any time I go too fast, please stop the video so that you can write these things down. Number 5, we're still factoring. We have x squared minus 16. Look in front of the x and see there's not a number, so it tells me there is no GCF. I'm looking for my sum and my product. My sum should be the number in front of the x. There is no number in front of the x, so the sum is 0. The product, we take the number in front of the x squared, the coefficient is 1, times our last, that gives us a negative 16. I need two numbers that will multiply to give me negative 16, but add to give me 0. I can't think of that off the top of my head, so I'll put it in a calculator. It's negative 16 divided by x, that's in y1. In y2, we have negative 16 divided by x plus x. Hit second graph, so I can go to my table. And this time I'm looking in my y2 column for the sum of 0. So I see I have to go upward in order to get smaller numbers in y2. And I find my two factors are 4 and negative 4. Now I can rewrite my answer. Write my answer. I have the variable x. I didn't have a GCF. My factors was a positive 4 and a negative 4. Number 6. First step, GCF. Look in front of the x. There was none. There's not a number there. No GCF. Step 2, our sum. Look at the number in front of the x. Our sum is negative 2. And our product, then it's going to be the coefficient of the x squared, which is 1. And my last number, 1 times 1 is 1. Find the factors. What two numbers will multiply to give me 1, but add to give me negative 2? This is going to be a negative 1 and negative 1. Negative 1 times negative 1 is 1, and negative 1 plus negative 1 is a positive 2. So we'll rewrite it using our parentheses, so it's in factored form. I have my x's as my variable, and then I put the factors in. X minus 1, x minus 1. We'll go on to number 7. 5x squared minus 80. So I'm looking for the GCF. See the number in front of the x squared is 5. 5 does go into 5, and 5 does go into 80. So I know my GCF is 5. Let's factor it out. I put the GCF out front, and then those 5's cancel. We're left with x squared, and 80 minus, or sorry, 80 divided by 5 is 16. Now we can do our sum and product. Our sum, there is no x, so our sum is 0. Our product, again, number in front of the x squared times our last, that'll be a negative 16. Last thing we do, I need two numbers that will multiply, give me negative 16, but add up to give me 0. Those two numbers are negative 4 and a positive 4. Write our answer. This time I do have a GCF, so I got to make sure I put the GCF out front, in front of my parentheses. My variables are x's, and now my factors are negative 4, positive 4. Number 8, looking for GCF. I see there's not a number in front of the x squared, so the GCF is none. We want a sum and a product. Our sum is the number in front of the x, that's 20. And our product, I take the coefficient of x squared, which is 1, multiply it times the last, 96. 1 times 96 is 96. Now I need two numbers that will multiply to give me 96 and add to give me 20. I can't think of that off the top of my head, so I will use my calculator. So we put in 96 divided by x. Hit delete to get rid of that negative, and then 96 divided by x plus x. Hit second graph to go to the table. My sum, I'm looking for 20 in the y2 column. And I can find 20 in the y2 column, so my other two columns tell me what the factors are. They are 8 and 12. So we will rewrite this in factored form. Our variable was x, our factors was a positive 8, so it's plus 8, and a positive 12, that is plus 12. Number 9, we have x squared plus 3x minus 18. I see there is not a number in front of the x squared, so that tells me the GCF is equal to, or is none. 2, my sum and product. The sum is the number in front of the x, that'll be a positive 3. The product is the coefficient of x squared times negative 18, so 1 times negative 18 is negative 18. I'm looking for the factors. What two numbers multiply give you negative 18, but add to give you a positive 3? Our factors are going to be 6 and negative 3. We can now rewrite. My variable is x, and my two numbers is a positive 6 and a negative 3. Number 10, start off with the GCF. I see the number in front of the x squared is a 5, so I put a 5, and then check. Can I divide 180 by 5? And sure enough, I can. There's no other x's, so it's just the number 5. So GCF is out front, and then we're left with 5x squared divided by 5 leaves me with x squared, plus 180 divided by 5 is a positive 36. I'll look for my sum. Has to be 0 because notice there is no x, and the product must be equal to 36. That'll be 1 times 36, my first times my last. Let's use the calculator again. Can't think of things off the top of my head. I think 6 times 6, but that doesn't equal 1. So let's try, see what we come up with. 36 divided by x, and then 36 divided by x plus x. Let's go to our table. And again, I'm looking for 0 in my y2 column. So I'm noticing something in my y2. As I scroll up, y2 is getting a lot bigger. As I scroll down, it is getting smaller. I got 12.5, and then it jumps back to 13, so now I'm going back bigger again. So this tells me there are no factors, no two numbers that will multiply to give me 36 and add to give me 0. So when I factored out my GCF, I have factored it completely. I cannot go any further. The farthest I can factor this is 5 times x squared plus 36. Number 11, look for a GCF. There is none. Then we look at our sum, the number in front of the x, that's the negative 2, our product, coefficient of 1 times negative 35, we got negative 35. I need two numbers that multiply give me negative 35, but add to give me negative 2. I know 7 and 5. One of them must be negative. Since my sum is negative, then the bigger number is negative. That's 7. So they do multiply, give me negative 35, add to give me a negative 2. We will rewrite, put our variables of x, and then put our factors, minus 7 plus 5. Number 12, first thing we're going to do, find GCF. Notice I have a 2, and I can check, yes, 6 can be divided by 2 as well as 36. So I do have a 2. I also notice that I have x's in every single one of our terms. And so I go with the smallest exponent, that'll be x. So my GCF is 2x. And then let's see what's left over. The 2's will cancel. X cubed, that's 3 x's on top. I have 1 x on the bottom. 1 will cancel out. I'm left with an x squared. Plus 6 divided by 2, that's 3. I have 2 x's on top, 1 on bottom. One of the x's will cancel. I'm left with an x on top. Minus 36 divided by 2, that's 18. And then my x's cancel out each other. I have no more x's there. Let's look for the sum. The sum is the number in front of the x. That's going to be a positive 3. On a product, coefficient of the x squared is 1 times my last is a negative 18. I need two numbers that will multiply to give you negative 18, but add to give you a positive 3. That's going to be 6 and a negative 3. So now we rewrite it. Don't forget your GCF is 2x. Must have that, and then we put x's, and we have a plus 6 and a minus 6. Our next one is asking us to solve by factoring. So we're still going to factor, but now we're going to go another step and actually solve. One of the things that you need to recognize is that I could ask you to solve, or I could ask you to find the solutions, or I could ask you to find the zeros, or a solution set. They all mean the same thing. I'm solving for that variable. So what number can I plug into the variable in order to get a true statement in the equation? So our first one is y squared plus 5y minus 24 equals to 0. Remember that the first step when doing these is that you must be set equal to 0. Our equation is set equal to 0, so now we can just factor. We'll go through our 4 steps of factoring. GCF, there is none. I'm still looking, sum and the product then. The sum is the number in front of the variable of the middle term, and so in this case it's going to be 5. Our product, we multiply the coefficient of the squared term times the last, and that'll give us a negative 24. I'm looking for two numbers that will multiply to give you negative 24, but add to give you 5. I can't think of those two numbers right off the top of my head, so I'm going to use the calculator. We'll go to y equal, take my product, negative 24, divide by x, and y2. Again, take the product, negative 24 divided by x plus x. Let's go to the table, hit second graph. I'm going to look for my sum of 5 and y2. And I see the sum of 5 is in y2. So my two factors are 8 and negative 3. Now rewrite this quadratic or trinomial in factored form. Our variables are y's. We have a plus 8 as a factor and a negative 3 as a factor. This is still set equal to 0. Since we are solving, it has that equal sign, so we have to say either this first term or my second term must be equal to 0 in order for me to multiply these two factors and get a 0. So we're going to set each one equal to 0. Y plus 8 equals 0. Y minus 3 equals 0. Solving for y, we'll subtract 8 from both sides. This will give us y by itself, and 0 minus 8 is a negative 8. Or, again, solving for y, we'll add 3 to both sides. This gets y by itself. 0 plus 3 is a positive 3. So the solutions, or the zeros, is y equals negative 8 or 3. As a solution set, the way you would see this answer as a solution set would be using our fancy parentheses and the two numbers in those fancy parentheses, that set notation. So here's another way that you can see the answer. Problem 14. First step is we need to have it equal to 0. If I have an equal sign, I need to get it equal to 0. So I also like my squared term to be positive. It's already positive, so that means we need to make our right-hand side equal to 0. I'm going to add a positive 1x and then subtract a negative 42. I chose those numbers because if I take a negative 1x plus a positive 1x, it equals 0. But I have to remember what I do to one side, I must do to the other side. So positive 42 minus 42 equals 0. I have 0 on my right-hand side. On my left-hand side, I cannot combine any like terms, so I get x squared plus a positive 1x minus 42 equals 0. Now we can factor like we've done before. See, GCF. I have none. There's not a number in front of the x squared. Second step, we need our sum and our product. The sum is the number in front of the x, that's a 1. And the product, we take our coefficient of x squared, multiply it times our constant negative 42, and we get negative 42. Third step, I need two numbers that will multiply to give me negative 42, but add to give me a positive 1. I know 6 and 7 multiply give you positive 42. I need to be negative. So one of these must be negative. I'll try negative 6. Negative 6 plus 7 does equal positive 1. I chose correctly. So now we will rewrite it. Our variables was x. We have an x up front, and then negative 6 and a positive 7 we fill in. Since we're solving, we have to set that equal to 0. If they are going to be equal to 0, then either the x minus 6 is equal to 0 or the x plus 7 is equal to 0. So now we need to solve for x. We'll add 6 to both sides to get the x by itself. This gives us x equals 6. And our other factor, we'll subtract 7 from both sides to get the x by itself. That gives us x equals a negative 7. So our answer is x is equal to 6 or x is equal to negative 7. Again, it could say your zeros are x equals 6 or x equals negative 7. And you could also see it as a solution set. So it should be a positive 6 and a negative 7. We say zeros because we're asking what does that variable have to be in order to make this equation equal to 0 or to make the factors equal to 0. Number 15, we have 0 equals x squared plus 5x minus 24. Notice this is really already in standard form. We already have all our x's and constants on one side. The only thing is that the equal to 0 is on the left. Well, I can move that to the right. It's still equal to 0. Now let's solve. Let's look for the GCF. GCF, there is none. There's not a number in front of the x squared. Looking for our sum. Our sum is 5. That's the number in front of the x. And our product, coefficient of the x squared times the negative 24. So 1 times negative 24 is negative 24. I'm looking for a number that's going to multiply to give me negative 24, but add to give me 5. I don't remember how to do that. I'll use my calculator. Looks like we just did this problem. So I'm looking for 5. That's 8 and negative 3. Those are my factors, so let's rewrite it. X plus 8, x minus 3, that equals to 0. In fact, it is the same problem. Notice the only difference is the same problem as number 13, except we have x's instead of y's, and it was already given to us in standard form, but it was equal to 0 on the left-hand side. This is going to tell us x is equal to negative 8 or a positive 3. Again, your zeros are -8 or +3, and as a solution set, we could write these in set notation. Number 16, we're still solving. We want a GCF. Notice it has an 8 in front of the x squared, so let's see if 8 works. Yes, 8 does go into 32. I don't have any x's there, so 8 is my only GCF. This leaves us with x squared minus 32 divided by 8 is 4, equals to 0. I now need to find my sum. There is no x value, no middle term, so that means the sum is 0. The product, coefficient in front of the x squared is 1, times the -4 is a -4. I need two factors. What's two numbers that multiply to give you -4, but add to give you 2? I'm sorry, add to give you 0. That's 2 and a -2. I got a little ahead of myself. We're going to rewrite this in factored form. I do have an 8 out front for the GCF. We put our x's. We have a +2, -2. And remember, this is now set equal to 0. So when you need to find what are those x values, I'll look at each factor. We go 8 equals 0. X plus 2 equals 0, x minus 2 equals 0. Notice that 8 equals 0, well, they're both numbers. There's nothing to solve. And this is not a true statement, so I'm going to ignore it. Now I have x plus 2. Let's solve it. We'll subtract 2 from both sides. That gives us x equals a -2. And then in our other factor, x minus 2, we'll add 2 to both sides, and that'll give us x equals a +2. So our answer is x can be a -2 or it can be a +2. Going to number 17. Looking at this one, GCF. We do have a number in front of the x squared. So GCF, let's check to see, does 7 go into all our terms? And 7 does go into 28, so that's a true statement. Also notice that they both have x's, so we're going to pull out an x also. Rewrite it. We'll take out a 7x. 7 divided by 7 is 1. X squared divided by x is x. Minus 28 divided by 7 is going to be 4. And then your x's cancel each other out. Still equal to 0. Notice inside my parentheses we don't have any more x squared terms, so there's nothing else to factor. This is already in complete factored form. So we take each factor, 7x, that's what's out front, equal to 0. X minus 4 equal to 0. Divide. Let's do the first one. We want x by itself. It's 7 times x, so we're going to divide by 7. The 7's cancel. We're left with x equal. And then 0 divided by 7 is going to give us 0. To get the x by itself from our other factor of x minus 4, we do the opposite of minus. We're going to add 4. This gives us x equals a +4. So our zeros, or our solution, is x is equal to 0 or x is equal to 4. Number 18. In order for us to solve this one, I know I need to solve because I have an equal sign and numbers on both sides. I need the right-hand side to be equal to 0. So that means, how do I get 0 on the right-hand side? I have a -121. I'm going to add 121. I'm doing the exact opposite of what's there. -121 plus 121, that gives us 0. And then whatever we do to the right side, we did to the left. We end up with x squared plus 22x plus 121. Let's start with the GCF. GCF, there is none. Second step, find our sum. Our sum is 22. It's the number in front of the x. And our product is going to be the coefficient of x squared. That's a 1 times 121. We get 121. Third, I need what two numbers multiply to give you 121? I recognize that as 11 times 11. If I didn't, I would use my calculator. But I'd check 11 plus 11. Yes, that does equal 22, so that's the correct factors. The fourth step, we're going to rewrite it. Our variables was x, and our factors now is plus 11, plus 11. Last thing we need to do is set that equal to 0, because now we need to solve. We'll set our factors equal to 0. Each factor, we have x plus 11 equals 0. And I noticed that my second one is the same thing. So I'm just going to write it once. We're going to subtract 11 from both sides. This gives us x by itself. 0 minus 11 is a negative 11. So I have one solution here, and that is negative 11. We're going to do a few review problems because your test is cumulative. Not only will it be factoring and solving, but it does review our previous work. So this first one says, which equation best describes the line shown in the graph? Looking at the line, you can see that the y-intercept, it's where we always begin, where it crosses the y-axis, is at a negative 1. And then we'll notice that our slope is positive. So I'm going to do this in pieces. First, understanding that the y-intercept is negative 1. All of these equations are in the y equals mx plus b form, which is slope-intercept form, because we can pick out the slope and we can pick out the y-intercept. In A, we have a y-intercept of positive 1, so it cannot be A. In B, we have a y-intercept of negative 1. That means it can be. C, we got a y-intercept of negative 1. And D, we have a y-intercept of negative 1. So we've gotten rid of 1. The other thing that we can know or notice is that it has a positive slope line. As we read it from left to right, it's going upward. So our slope must be positive. That's the number in front of the x. B has a positive slope. That means it could possibly be it. C has a negative slope. We'll cross it out. And D, we're left with, it does have a positive slope. So now we've narrowed our choices to B and D. I'm going to use those answers in order to see which one matches. I could calculate the slope by picking 2 points on the line, and then I would count how far I go up and down, and then how far I go to the right, and that would tell me my slope. But since they give me answers, I'm going to use what they give me. Again, this slope in B has a slope of 2 over 3. So I'd go up 2 and then to the right 3. So let's find out. If I start at one point and go up 2 and then to the right 3, I am not on that line. So B cannot be my answer. Let me check D. If I go up 3, 1, 2, 3, to the right 2, 1, 2, I find the point on the line. So sure enough, my slope is 3 over 2. So my correct answer is D. 20, we are solving because we do have an equation. It is set equal to a number. This is not one of those quadratics, so we have to go through our steps of solving. We're going to draw a line down the equal sign. And notice we do have a parenthesis, so we're going to distribute the negative 3 inside the parenthesis. That means everything inside the parenthesis needs to be multiplied by negative 3. The 5x was not multiplied by it, so I'm going to write it down. Nothing happens to it. And then I'm going to show my work. We have a negative 3 times a 4x. And then we also have a negative 3 times a negative 2. On the right-hand side, we still have 20. Didn't do anything. So multiply that out. Negative 3 times that 4x is a negative 12x. And negative 3 times a negative 2 will be a positive 6. We've taken care of the parentheses. Now I see I have some like terms on the same side, so I can add the 5x and the negative 12x. So 5 minus 12 is going to give me a negative 7x. Notice I'm just combining these terms. So plus 6. Still haven't done anything. Now I can solve for x. I'm going to box my variable with the coefficient. I need the negative 7x by itself, so let's get rid of the 6. We're going to subtract 6 from both sides. And it gives me a negative 7x. It's still in my box. Positive 6 minus 6 is 0. I did the right thing. And a 20 minus 6 is 14. I want the x by itself. I have a negative 7 times x, so to get rid of the negative 7, we're going to divide by negative 7. That negative 7 was in the box. I don't change its sign. I'm getting rid of it by division. So the negative 7's divide out. This leaves us with x by itself. And then 14 divided by negative 7 gives us a negative 2. So our solution is x equals a negative 2. Again, I could check that by plugging that back into my equation. Everywhere I see an x, I'm going to put in a -2. So 5 times a -2, put in parentheses, I have -3. Open up my parentheses, we have 4, and then it's going to be multiplied times a -2, and then -2. That's just the left-hand side. I'm going to press enter and see if I come up with 20. I sure did. This is a true statement, and so this is a solution is -20. So I can always plug in a number and see if I get a true statement to find a solution. 21, I want the function that contains the point 3, 7 and has a slope of 4. Our functions are in slope-intercept form, so y equals mx plus b. I'm going to use capital B because my b's look like 6's. What they give us is a point, so I got an x and a y value, and I also have the slope, which is the 4. So I'm going to plug those numbers in. For y, we get a 3. My slope is 4. The x is 3, and I need to figure out what is b. So we have 3. Multiply the 4 times 3, that's 12, plus b. I want to get the b by itself, so we're going to do the opposite of a positive 12 and do a minus 12. 3 minus 12 is a -9. I messed up. My y value is actually 7. So this should be 7, and this should be 7. Sorry for the confusion. Hopefully somebody else has yelled out that you did that wrong. So let's try that again. 7 minus 12 is a -5. And then 12 minus 12 is 0. That leaves us with the b by itself. We now know what b is. So my equation, or the function, is y equals, we have our slope is 4, then x, and then -5. Number 22, this is, can we write a system based upon a word problem? We have Frosty Ice Cream Shop sells sundaes for $2 and banana splits for $3. So I know each sundae is going to be $2 a piece. And I know each banana split is $3 a piece. On a hot summer day, the shop sold 8 more sundaes than banana splits and made $156. Which system of equations could be used to find the number of sundaes S and banana splits that the shop sold that day? So let's look at the numbers that they give us. This 2 represents a dollar amount. The 3 represents a dollar amount. So I need dollar amounts to go with dollar amounts. And I have 156 with the dollar amount. So I need an equation with the 2s and the 3b relating to 156. I see 2s plus 3b, and a equals 156, so that works. B, it has 2b. Well, bananas do not cost $2, they cost 3, so immediately that tosses out b. C, we have 2s plus 3b. All right, I got the 2s, the sundaes, and the bananas, and it says equals 8. Well, no, it needs to equal a dollar amount, so C is out. D, 2s plus 3b is 156. That one works. So I've taken care of the numbers that have $2 and the $3 and the 156. What I also have is that they tell me that the shop sold 8 more sundaes than banana splits. So you have to ask yourself, which one did they sell more of? I have more sundaes. So the equation I look for needs to have S by itself because that's what I have the most of. Well, I can then discount D because it says B minus S. S is not by itself. But let me check just to make sure. I have 8 more sundaes than banana splits. More than tells me I need to add. So I'm going to have the number of bananas and add 8 to it, and that'll give me the number of sundaes. And this does make sense. If I had one banana split, I'd have 9 sundaes. So I do have more sundaes. This is the one, A, then it's going to be the one that is the best answer. D is gone. 23, this has to do with our exponents and multiplication. So we're going to start off by putting your numbers first and then the variables like variables together. It's all multiplication. So numbers, we have 2 from our first parenthesis, and -2 from our second parenthesis, and 3 from our last parenthesis. Then we're going to put our A's together. We have A from the first parenthesis. I don't have any A's in the second parenthesis, but I have A squared in the last one. A squared means AA. We're going to stamp it out twice. Now look for the B's. In the first parenthesis, I got 3 of them, b cubed, so it's 1, 2, 3. Second parenthesis, I only have 1 b there, so 1. And last parenthesis, just 1 b there. Now we're going to multiply. We have 2 times a negative 2, that's a negative 4 times 3, that's a negative 12. Or I should say we're simplifying. A times A times A, that's 3 of them, so that's A cubed. We're just working backwards from the stamp. And then B times B times B times B times B, that is a total of 5B, so we put B to the 5th power. So simplified, we get negative 12 A cubed B to the 5th power. Number 24, we have, again, some more exponents. This time, notice you do have numbers outside the parentheses. So that tells me I need to stamp out what's in the parentheses 2 times. So 2ab squared, and then 2ab squared. That takes care of my first set of parentheses. The second one, I have a 2 outside the parentheses, so I need to stamp it out 2 times. Negative 3a squared b, that's 1 time. Negative 3a squared b, that's 2 times. Now this problem is just like the previous one. Let's start with the numbers. 2 times 2 times a negative 3 times a negative 3. So I'm crossing them out as I go along. And you can use parentheses or the little dots. I switch back and forth, as you can tell. From the first parenthesis, there's 1a. From the second parenthesis, there's another a. From the third parenthesis, I have a squared, so it's 1, 2. And the last parenthesis, a squared again, so 1, 2. Let's do the b's. From the first parenthesis, we have b squared, so 1, 2. And then we have b squared in the second one, so 1, 2. And then 1b from the third parenthesis, 1b from the last parenthesis. Let's multiply. 2 times 2 is 4, times 3 is negative, times a negative 3 is negative 12, times a negative 3 is a positive 36. So this comes out to be a positive 36. And then let's count our a's. 1, 2, 3, 4, 5, 6. So this is a to the 6th power. Count our b's. 1, 2, 3, 4, 5, 6. This is b to the 6th power. Okay, the length of a rectangle is 3x plus 2. The width is 3x minus 4. We need the area of that rectangle. So let's write 3x across the top plus 2. And then the width is 3x minus 4. Let me draw another picture so you know why I drew that box. If I drew a rectangle and had a length of 3x plus 2 and a width of 3x minus 4, it says it wants the area. The area is length times width. So my length is 3x plus 2. The width is 3x minus 4. I'm multiplying those two things together. You can do the tornado or foil method, or you can, see, I always get these confused. I need to do here. So I don't use foil. Or I can use, let me stop that. I like to use the box method. It's just a great visual for me. My way of graphic organizer. So 3 times 3x. 3x times 3x, this gives me 9x squared. That would be the first times the first. Then we have 3x times 2. So 3x times 2, this gives me 6x. Now we get 3x times a negative 4. So 3x times a negative 4 is a negative 12x. And we have negative 4 times 2, and that is a negative 8. So there we go. That's how it will look if you were doing the tornado method. All right. Now I'm going to take what's in my box. I'm going to bring it out, and this is 9x squared. Combine the diagonals. So this will be 6x minus 12x. That gives me a total of a negative 6x, and then a minus 8. The area of that rectangle is 9x squared minus 6x minus 8. We want to find the area of the rectangle below. Asking the same type of question. Again, I'm going to use my box. It's my visual. We have 2x plus 7. That's across the top because that's my length. times my width, 3x, and then plus 2. Now let's multiply them. 2x times 3x is a 6x squared. 7 times 3x, that's a positive 21x. 2x times 2, that's a positive 4x. And 7 times 2 is a positive 14. The area then, let's take it out of the box. We have 6x squared. We'll combine 21x plus 4x gives me a 25x, so this will be plus 25x, and then plus 14 is the area of the rectangle in terms of x. 27, we want to see what happens. We have an original graph, and on the same grid, we're going to graph our new function and then see which one is true. Because these have already given me the equations and y equal, we're going to put them in the calculator and let the calculator graph for us. So my first equation will be with y1. Let's clear everything out. We type in 2/5, so 2 divided by 5. I like to put my fractions in parentheses. X and plus 4. And my second, y2, we're going to put 5 divided by 2. X, and this is also plus 4. Some of you already may recognize, hey, these have the same y-intercept because we have the plus 4 there. We can also see that their slopes are not the same. One is 2/5, the other is, sorry about that, the other is 5/2. Well, let's look to see what that graph looks like because everything here says it's all about the graph. Here's my y1, that's the first graph. There's y2, that's the second graph. So I'm going to do a little trick, which wish you could do it. I know you can't, but wish could. But that way I can, so this is what y1 should look like if I was to graph it. And then this is my y2, what it looks like if I was to graph it. So let's look. It says the graph of your original function, that's going to be what I put in y1, is steeper than the graph of the new function. Steeper means more vertical. Well, I can look and see that y2 is more vertical than y1, and so this is a false statement. Then the graph of the original function is parallel. They're definitely not parallel. I can stop right there at that word because they are touching each other. Graphs intersect at 4, 0. Let me look at my graph. 4, 0, this is the x-coordinate, y-coordinate is 0. So 1, 2, 3, 4. 4, 0 would be this point. That is not a true statement. D says the graphs intersect at 0, 4. Hey, that's another way that I can show my y-intercept. And I already recognize they have the same y-intercept, so sure enough, my correct answer is D. Just another way you can use your calculator to help you out. 28. So which of the following inequalities best describe the graph shown below? So notice that this graph shown, it is a solid line and it's also shaded below. So with a solid line and shaded below tells us it's less than, the solid line tells us that we'll have an equal to, and sure enough all those have that same thing. Next thing I'm going to look at is my y-intercept, because when I graph, we start with the y-intercept. Notice this y-intercept is at -2. So we'll check and see. All of these have a y-intercept at -2. That doesn't help me out. Next, I want to figure out then what's my slope. Well, first of all, I notice if I read left to right, I'm going in downward direction, so my slope is negative. Knowing my slope is negative, that crosses out A. It also crosses out B because they had a positive slope. To figure out my slope, I'm going to do 2 points. And the slope always counts how far you go up or down over how far you go left or right. So I'm going to go down 1 and then to the right 1, 2, 3, 4. My slope is a -4. My answer is D. Number 29, which of the following best describes a line containing the points -1, -9, and 0, -7? I'm going to recognize that this is my y-intercept, so it should have a y-intercept of -7. That gets rid of C and D. So I need to know which one of these two lines contains the point -1, -9. I need to stress there's more than one way of doing these problems. So I'm going to use my calculator though, because they're giving me answers. The first one is -2x minus 7. So I type in negative 2x minus 7. And then I'm going to look at my table by hitting second graph and see, can I find the point negative 1, negative 9? So I'll go where x is negative 1. This says if x is negative 1, my y value should be negative 9. That tells me this point is not on there. So A is now good. I can check B. This should be a positive 2. Let's get rid of the negative. So positive 2x minus 7. Let's check the table and see. When x is negative 1, y is negative 9, that point is on that graph. And so I have my correct answer. I also see my other point, 0, negative 7, which I already knew it was there. Right, last two problems. We have the area of a rectangle is represented by the equation y squared minus 7w equals 18, where w is the width of the rectangle. Find the width of the rectangle. So this time they're giving us the area. Remember, area is length times width. So the area is, I'm confusing this with the one below it, but let's go ahead and do it. Y squared minus 7w, or w squared, equals 18. You notice you have an equation, it's equal to 18. Well, we can solve this because it is also a quadratic because it's a squared term. In order to solve it, we need it equal to 0 though. So we're going to move the 18 to the other side. That gives us w squared minus 7y minus 18 equals 0. The only difference between these problems and our other ones that we solved is that this is w instead of x's. Let's go through our steps. Does it have a GCF? The number in front of w is 1, so that tells us no, there is no GCF. 2, we're looking for the sum. That's the number in front of the variable or the middle term. That'll be a negative 7. It's a non-squared variable. And then our product, coefficient of w squared is 1. Multiply it times the negative 18, we get a negative 18. We're looking for the factors. What two numbers multiply give you negative 18, but add to give you a negative 7? It's going to be a negative 9 and 2. If I add them together, I get negative 7. Multiply, give me negative 18. And so then last, I will rewrite this in factored form where my variables are w's. We have a minus 9 plus 2, and it's set equal to 0 because I am trying to solve it. So to solve it, we take each factor. W minus 9 must be equal to 0, or w plus 2 must be equal to 0. To get 0 in this first parenthesis, w comes out to be 9. To get 0 in the second parenthesis, w must be a negative 2. So this is asking us what is the width. My width, then, when I answer the question, I am talking about an actual measurement. I cannot have a negative measurement, so the width has to be a positive 9. Our last problem they give us, which is one I started on, the area of the rectangle is 30 a to the 8th b to the 5th square units. If the length is given as 6a cubed b squared, how many units wide is the rectangle? This is where we need to know. Area is the length times the width. Notice it is not asking us to find what the width and the length are. Also, you also have two variables rather than one. So they're giving you the area. We know that that is 30 a to the 8th b to the 5th power. The length is also given. That is 6a cubed b squared. And what you need to find out is what's the width, what goes in this blank here. So there's a couple ways that you can do this, but I really like one way. One way is to divide the 30 a to the 8th b to the 5th by our length. Okay, so one way is to find the width is to take our area and divide by the length. That's one way. I like multiplication better than division. So what I like to do is take the number for the area. It should be equal to the number I have for the length times the number I have for the width. So 6 times what number is going to give us 30? And that would be 5. 6 times 5 equals 30. Then I'll look at my variables. I have a to the 8th, that's on my area side. The length gives me a cubed. I need to know what the width is in order to get this a to the 8th. Well, if there's 8 a's on the left, I have 3 here. That means I need 5 more, so a to the 5th. Last, I have b to the 5th. It's part of the area. The length gives me b squared. I need to know what the width is. If I have 5 b's on the left and I have 2 on the right, I need 3 more in order to make it to 5. So my width then is 5 a to the 5th b cubed in terms of a's and b's. Okay, this concludes the review for Unit 14. Good luck on your test.